If you do need a dedicated line to Azure that won't go over the public internet, you can look at Azure ExpressRoute as an option. Now that connection can be provisioned up to 10 gigabits per second, depending on the provider who's providing this connection. And it can support dynamic scaling of bandwidth. So you're not always paying for the largest amount of bandwidth you think you might need. You can scale up when you need it. Now, again, this does depend on the capabilities offered by the ExpressRoute provider in your local area. But the key point is that this traffic between you and Azure via this ExpressRoute connection will not pass across the public internet. And because of that, you get this benefit of a 99.9% availability service level agreement of this entire connection. Remember, that's different to the VPN, where Microsoft was only guaranteeing their VPN gateway at their end. That all sounds pretty good, but there are a few considerations with Azure ExpressRoute. For one, it's not available in all locations, so you're more likely to find it in some of the major cities, for example. The architecture itself can be quite complex to configure, and you do have to deal with a third-party connectivity provider. So they are the ones who are provisioning this network for you to use. You also need some pretty high bandwidth networking equipment on your on-premises sites. I did warn you that the ExpressRoute architecture was a little bit more complicated, so let's break it down. To start with, we have our on-premises network. So that's just your standard office location with your VPN appliance as your gateway. Then you have the ExpressRoute circuit itself. So this is provisioned by your provider, and it's a layer 2 or layer 3 network circuit. It joins your on-prem network with Azure through the edge routers. And those edge routers are hardware that is provided by and managed by the connectivity provider. So you have local edge routers on the on-premises side of your network, and then you have the Microsoft edge routers, 2 routers in an active, highly available configuration. You've then got your Azure Virtual Network, and we have a gateway subnet again, but this time instead of having a VPN gateway, we've got our ExpressRoute gateway connection in that gateway subnet. And then different network subnets for your web application and those virtual machines, business applications, for example, and your data storage that are individually protected by network security groups. One of the challenges around a hybrid network deployment will be determining how to route traffic between offices and whether or not each office requires its own independent VPN or ExpressRoute connection into Azure. Now, this leads us in to look at Azure Virtual WAN, which might solve both problems. So Tailwind Traders needs to ask whether their on-premises offices are in multiple regions. Have they deployed resources into multiple Azure regions? Whether each on-prem site should have individual connectivity to Azure, and whether or not those sites need VPN or ExpressRoute connections into each Azure region. You can start to see how all of these different questions and challenges and individual business requirements help you formulate the decisions you make about how this hybrid network topology is going to be configured. With Azure Virtual WAN, we can provide connectivity between 2 of your different physical on-prem branches through Azure itself. This gives us an automatic site-to-site configuration and connectivity between these on-prem sites and an Azure hub. In essence, it gives us an automated spoke setup and configuration when we step through the processes, and a built-in Azure dashboard to give us some troubleshooting insights and view our connectivity on a larger scale. It's important to know with Azure Virtual WAN, you can have up to 1,000 connections per virtual hub, but each connection has 2 tunnels in an active configuration. So it has 2 network tunnels going all the time that your traffic is going to be split between, giving us a level of redundancy, but it means that we don't have a secondary connection that's sitting there dormant, not being used. Also, our on-premises VPN devices can connect to multiple Azure Virtual WAN hubs. We take a look at the Azure Virtual WAN architecture. You can see that we've got the Virtual WAN inside Azure, in essence being our hub and our hub and spoke topology. And our spokes can be anything from our physical on-premises branches through site-to-site connection. Those branches could be connected via ExpressRoute, and we could also have remote users with individual connections from their devices in a point-to-site VPN configuration. Through those, we also connect to our different virtual networks inside Azure, and then all of these different endpoints can communicate with each other. It's time for another demo, so let's jump into the Azure portal and look at how to set up an Azure Virtual WAN. Instead of using a traditional network hub and spoke topology, we're going to use VPN connections from each of our branch site offices into Azure, and then we use Azure as the backbone to connect those sites to each other. This removes the reliance on your one hub site, because if that goes down, it could potentially take down communications from your branch sites to each other. Inside the Azure portal, we'll start in the marketplace and search for Virtual WAN. So it's Microsoft's Virtual WAN offering here that we need to go and create. This becomes the container for all of our network connections. Now we have the standard options here when you're creating any resource in Azure, including which subscription they're being placed in, which resource group, and I've got one I've already created, and then the location of that resource group. So we'll go and change that one to East US. I'm going to give it a name. And here I get to choose what type of virtual WAN. There's two types, standard and basic. Now, standard allows for a wider range of connectivity options than basic does, and that includes things like ExpressRoute and user VPNs, known as point-to-site VPNs. The basic type for a virtual WAN only supports site-to-site VPN connections, but it's priced cheaper. We'll leave it as standard for the demo. It'll validate against any Azure policies, and it will go and create that virtual WAN resource for us. Now, I've sped that up. It might not take quite so quickly, but I figured you didn't want to sit and wait for it to complete. Inside the virtual WAN itself, we'll start by creating a virtual hub. So this is your Microsoft managed virtual network, and it contains various service endpoints to allow connectivity. Just note that you can only have one of these hubs per Azure region. With this network topology, your site-to-site connections come into this hub, not into VPN gateways on any individual Azure virtual networks where you have your resources. Again, because we're creating a new Azure resource, we get to pick things like the region. It's given us a default subscription and resource group that we were already in for the virtual WAN. And then we get to put in the particular endpoint connection types that we need. So we'll start with a site-to-site VPN gateway. This allows your hub to have your site-based VPN connections coming into it. And when we create this site-to-site VPN gateway, it's going to ask us for the gateway scale units. Now this is the maximum total throughput of this VPN gateway. And it always gives us 2 instances for redundancy, but here we've got a maximum of 500 megabits per second of throughput. So you just need to work out this number based on the number of branch sites that you have and their maximum throughputs. For this demo, we're not going to create point-to-site or ExpressRoute connections, and we don't need to tag it, so we'll go ahead and create it. Again, it'll validate against Azure policy, and there is a warning down the bottom to say that this will take half an hour. I'll speed that up for you so you don't have to wait. So now our deployment has been created. We go and have a look at that hub resource that we've just created. And then we can go back to our virtual WAN and we can see this alpha hub listed. Once we have our hub, we're going to create a VPN site connection. This is the Azure side of the site-to-site connection from one of your branch offices. Again, because it's an Azure resource, we need to put the region in. And we want the region where that branch site office is going to be connecting in from, the closest Azure region to that physical location of our on-premises office. I'll create one from Melbourne, Australia, and add in the device vendor name of the VPN appliance. Next, you can turn on Border Gateway Protocol, or you can specify the private address space of that branch site office. Border Gateway Protocol offers dynamic routing, but your on-premises firewall needs to support it. So to keep it simple for this demo, we'll just specify the on-premises private address space of that office. And we want it to connect to that hub resource that we just created. I'm going to enter the link name, the internet provider name, and the speed of that particular branch link, and the IP address of that on-premises gateway device. Let's review and create that. And now we have this VPN site set up, so the Azure side of that Melbourne VPN connection. And I can go into Melbourne now, and under these VPN site-to-site connections, I could download the VPN config if I wanted to then go and set up the VPN gateway on premises. I'm going to go and set up a second site though. So let's get Sydney connected in. Again, putting in the name and the vendor of the firewall appliance that's there, creating an address space for it, and connecting it to that same Alpha hub that Melbourne is connected to. We'll put in a link name, the provider name, the speed, and the IP address of that device in Sydney, and go ahead and create that resource. So now we've got a second site in here, and we can see all the details of that. And if we go back under our virtual WAN and look at our VPN sites, again, we can download the VPN config. So that's going to give us all the information for configuring the on-premises side of these firewalls. In JSON format, you can see that it's got all the information in there about the VPN connections that we need to configure on those devices. So far, we've connected two sites, Melbourne and Sydney, to each other through our hub. Now, if you wanted to create individual devices to connect using a point-to-site VPN, you could use this Create User VPN configuration here and add those kind of point-to-site VPNs. We won't do that for the demo, but instead we'll look at adding an Azure Virtual Network connection. So if you have virtual networks in Azure that have got cloud resources in them and you want those sites to connect, we can add the Azure Virtual Network into the hub so that Melbourne and Sydney can connect to these resources in the cloud too. Add a new virtual network connection and connect it to our hub, and again choose a subscription and a resource group, and connect it to our VNet Alpha, our virtual network that already exists inside Azure with some resources in it. Next, you do have the capability to build some different routing tables and configure different static routes, for example, for more complex networks. We don't need to do that here, so we'll just use a default route table. And we'll create this virtual network connection. Let's go and add another one. We'll call this one Beta, and we'll pick the same hub to connect to. But this resource group and virtual network is in maybe a different Azure data center, and we'll add it to the same route table. Okay, so now we've got two Azure virtual networks connected to our hub with our two sites, and they're all routing with each other via this hub and spoke topology, all inside Azure. Once we have our networking topology figured out, how do we handle identity? If we've got user accounts sitting inside Active Directory in our Windows server on premises, we have a number of options for how we can configure our Azure resources to be able to use those identities. Our options start with our Active Directory domain services inside Azure. So this is where we are deploying servers that are running Active Directory as domain controllers inside Azure as virtual machines, as a separate site, a forest, or a domain. And they're connected back to our on-premises environment and our other domain controllers using a VPN connection. We could also use Azure AD Connect. So with Azure AD Connect, we can synchronize those identities from our on-premise Active Directory into Azure Active Directory. And then the resources we've got inside Azure will use Azure Active Directory to authenticate and authorize those user credentials. It means that the login process happens and the Azure resource doesn't have to try and communicate back to a domain controller on-prem to do that authentication and authorization. Now, another option is Azure Active Directory Domain Services. And with Azure AD DS, it's domain controllers as a service, where Azure provides a service that acts like an Active Directory domain, but you don't have any domain controller virtual machines to manage and operate. With this, we can domain join our virtual servers that are sitting inside Azure to our domain. When we're talking about Active Directory domain servers inside our Azure architecture, this diagram shows Contoso.com having a physical branch with their VPN gateway and their standard Active Directory servers. They connect to Azure through their VPN gateway. And then inside the virtual network in Azure, we have these ADDS servers. We're putting them in a separate subnet, and we're protecting them with a network security group to provide a firewall to protect against unexpected traffic sources. Now, that gateway connection between the on-prem network and Azure provides the synchronization between the Active Directory servers that we have on premises and the Active Directory servers that we're running in the cloud. With this configuration, you are still responsible for sizing the virtual machines inside Azure for these domain controllers and managing them like you would a standard on-prem AD server. Azure AD Connect is a different architecture because we don't have those domain controller servers anymore inside Azure. Instead, in our on-premises network, we have our standard domain controllers and our clients, but we also have a server that is running the Azure AD Connect sync service. Now, it's responsible for transferring the data between the information inside the domain controller in our on-prem Active Directory into our Azure Active Directory tenant. There are some technical details in terms of password hash sync and password write back and how all that works, but this isn't a pure identity session. So if you'd like some more information on that, check out the information at docs on Azure AD Connect. But just briefly, from a sync perspective, we have this automatic sync going on in the background that keeps up to date with changes in your on-prem Active Directory and synchronizes information through to your Azure Active Directory tenant. Your on-prem Active Directory remains the primary source of authority for creating new user accounts, changing details about those users, for example, and it will synchronize those changes through to Azure AD. It's important to note that that sync is never synchronizing a copy of what the user's password is. It's synchronizing a hash of that password. It's demo time again. So let's say that Tailwind traders have a server, a Windows Server virtual machine sitting inside Azure, and they'd like to be able to sign onto that Azure VM using credentials that are inside their on-prem Active Directory. This demo is going to step through the process of creating a virtual machine and enabling it to be logged into using credentials from Azure Active Directory. Now, this is different to using Azure Active Directory domain services, where we would actually domain join that Windows server to a domain. So this doesn't do that, but it still lets you log in with an Azure AD account. Now, that Azure AD account may have been created inside Azure Active Directory natively, or it might be syncing from an on-premises AD environment. There's some important steps that we need during the creation of this virtual machine. So in the Azure portal, we'll go to virtual machines and we'll add a new VM. We'll put it into an existing resource group. So we have one here called Hybrid VM, and I'll give it a name of Server 02. Now, like any VM, we have to pick a region, but the interesting thing here is which particular operating system that we're going to use. It's important to note that there are only two types of operating systems that this particular scenario will work with, one of them being Windows Server 2019. So it has to be a minimum of that Server 2019 version, or it also works if you're creating a Windows 10 VM. We'll leave the defaults here for size and we'll create an administrator account. Remember, with Azure, you can't use administrator as the username, so we'll call it Prime. And of course, we have to put in a complex password and verify it. Now I'm going to leave port 3389 open. And bonus points if you gasped a little here. It's not a recommended configuration to leave 3389 open on your servers, and you should be restricting network access to that port or leaving that port closed and using something like Azure Bastion for a secure connection. But that's kind of outside the scope of this demo. For now, just to make it easier to connect via RDP to show you some capabilities, we are going to see a few warnings from Microsoft to remind us that opening up port 3389 on this server to the entire internet is probably not the best idea. Then we'll step through the disks and the networking. There's nothing in particular we need to change here, so we'll just leave this at the defaults. And here again for the virtual network and all of these network settings, again, 3389, yes we know. We'll leave it on for this demo. The management tab is where we need to change some settings, and we need to change them when we create this virtual machine. The management tab is where we need to change some settings. Now the review and create box is blue, which means we could go and just create a VM now with all of these defaults set, but there are two particular settings that we need to change in here. If we scroll down first to identity, we need to turn System Assigned Managed Identity on. This provides an identity for this Azure resource, our virtual machine, inside Azure AD, and it can use that identity to obtain Azure Active Directory tokens. And we also need to turn on Login with AAD credentials. I'm going to turn off auto shutdown because I don't want this computer to turn off, and I can leave the rest as the defaults. Finally, in advanced, there's no specific extensions or anything that we need to install, and I'm not going to bother tagging this demo machine. So now it's going to go through the review process and check that all of these settings that we've put in place for this virtual machine that we want to create aren't contradicting any Azure policies that are being enforced in this place where we're creating it. And when that validation has passed, we'll go ahead and create this virtual machine. So it'll go through and create all the required resources for that VM. And then we can go back to our virtual machines pane and we should see this virtual machine has been created and it's running. Now let's go take a look at Azure Active Directory. You can see I've got a big list of users here. For testing purposes, I've got Gamma user and Jupiter and Mercury, Venus. And if I go and take a look at Jupiter, for example, you can see down the bottom that the source says that this is an Azure Active Directory user. So this account was created natively in Azure AD. Going back to our server, we need to assign some roles. So in the server properties, we want the access control tab. That's where our resource-based access control role assignments are granted. We're going to go and create a role assignment here for the people to log in. Now, the roles that we are looking for are either virtual machine administrator login or virtual machine user login. And the people that you want to be able to log in and have access to the server using their Azure AD credentials need to have one of those two role assignments set in the access control tab on the server that they're logging into. I'm going to do this with an individual user for the purposes of this demonstration, but you could put a group name in here instead and then add the users to that group. So we'll go and save that role for Jupiter. We're giving them virtual machine administrator access, which means that they'll be able to administer that server as part of the server's local admin group. Now remember that adding those role assignments can take up to 30 minutes to apply. So if you go and try and log in to the server straight away and it doesn't work, it might just be that that RBAC assignment has yet to be completed, actually being assigned into the server. I'm going to go ahead and connect via RDP. I've given it some time and sped it up for you, downloading the RDP file and connecting to the server. Now there's a bit of a trick here when you use this connection. When we go connect, we need to click on more choices. The RDP connection has defaulted to the administrator username that we created when we created this VM, but we need to change that and put in a specific format. So we'll choose use a different account, and you just have to be very careful how you format these login details. What you need is Azure AD / as the domain name, and then the full UPN, this unique name of the user's account. In this case, it's jupiter@tailwindtraders.net. And if we put in there Azure AD password and go and log in, it's now going to authenticate with Azure Active Directory for that user, but let me log in into this particular server. Remember, we set up Jupiter as being a virtual machine administrator login. So they've got the option in here to shut it down, but we're going to disconnect from this session to leave the server running. Let's go take a look at a different user account. If we go back to Azure Active Directory, and we'll use Mercury Venus. Now with Mercury Venus, you can see that their source is set as Windows Server AD. So we know that this account was initially created in an on-premises environment inside Active Directory from Windows Server, and it has been synchronized into Azure Active Directory. So similar process, we need to go back to our virtual machine and to our access control blade. And this time we're going to add a role assignment in here. So we can see we've still got Jupiter, but we're going to add a role assignment for this other user. So we'll also make them a virtual machine administrator login, give them that role, and add Mercury Venus. And once that role has applied, let's go and test the connection with this user. So remember that this user has been synced into Azure Active Directory from an on-prem Active Directory environment. Again, more choices, and we use that particular formatting using a different account with this Azure AD / and then the unique name for this Mercury user. Now it's going to connect and log us in successfully to the server. The virtual machine user login role, they wouldn't be able to shut the server down. They'd only be able to disconnect their session, because of course we don't want users shutting down the server thinking that they're logging off and shutting it down for everybody. And that's the end of this demo. You've seen the 2 key things you need to change when you set up the virtual machine to enable this functionality, and then how you need to add the role assignments for the people inside Azure AD that you want to be able to log into the server with their Azure AD credentials. And that works whether they're native accounts or they're synced accounts. This session has thrown a lot of complex terms at you because we've looked at both networking and hybrid identity. What we've ended up though is some scenarios where Tailwind traders can use Azure VPN and ExpressRoute to connect their branch offices to those resources and workloads in Azure without making those cloud resources available to the public internet. They've also explored how they can use ExpressRoute to ensure that network traffic from specific offices into specific workloads and resources in Azure doesn't cross the public internet, that network traffic. And they've now established an Azure Virtual WAN, so they've simplified their entire networking topology, both between their offices and the cloud and between their branch offices and each other. And finally, Tailwind Traders has explored how to use Azure AD Connect and Azure AD Domain Services to restrict access to resources and workloads in Azure data centers using the on-premises identities that they already have. If you're interested in delving into the technical aspects of these concepts further, there are some great resources at docs.microsoft.com. I'll leave them here on screen for Azure VPN and ExpressRoute, the Azure Virtual WAN, and the hybrid identity scenarios. Hey, thanks for your time. I hope this has given you some ideas to explore for how to configure your networking and identity options between your on-premises networks and Azure. We've explored solutions to Tailwind traders' requirements for network connectivity to cloud resources and for simplifying networking between their branch offices. You've also learnt about the options for using their on-premises Active Directory identity platform to integrate with Microsoft Azure for authentication and access to their cloud workloads. We will now take a 10-minute break. See everyone back here soon, then we will finish part 1 of our event with Module 3, Hybrid Cloud Applications.